Hey folks, this is Ted from American Rifle Company. I'd like to introduce you to our new Nucleus bolt action. Now this is a 3-lug bolt action requiring 72 degrees of bolt rotation, and I chose to do a 3-lug at the behest of some friends and customers and as a complement to the Mousing field, which is a 2-lug. A lot of people have asked us for a 3-lug action, believing that a shorter or less bolt rotation required to cycle the bolt reduces the disruption to their position when shooting. So, a brief overview: it is a Remington Model 700 compatible action, meaning the aftermarket goodies designed for the 700 will function within this action, those being triggers, AICS pattern magazines, and chassis systems. The barrel thread is Savage small shank. That thread is 1 1/16 20 unified class 2B properly. Class 2A would be its male counterpart that's found on the barrel that screws into it. I'll show you the bolt stop real quick since I have to remove the bolt to tell you about this next part. But the bolt stop obstructs a lug at 12 o'clock. It's easily actuated. It's right here. You just flip it over, bolt comes out. So it is a 3-lug action. You can see 1, 2, 3 lugs. Bolt stop stops the 12 o'clock lug. The lugs are toroidal, just like those of the Mousing field, so lapping is not required. You get good lug contact because the contact between the bolt lugs and the receiver is insensitive to the rotation or to the alignment of the bolt within the receiver. The bolt heads are interchangeable, and the bolt heads will be offered in sizes all the way down to from 223 all the way up to the 532 case head, which is like a 300 Win Mag. I don't think that I'm going to do this in a 338 Lapua Mag or the Norma Magnums or the Norma cartridges. So that would be like that's like the 580 case head. We're not going to do that. It's actually, I think, 589 or 590. But yeah, so 223 on up through 300 Win Mag. We've also had requests for the Valkyrie, which I think is a 420 case head, and we are doing that as well. So, what else can I tell you about this? We said 72 degrees. Okay, yeah, another thing is people have been, a lot of requests or a lot of questions regarding the effort required to lift the handle since it is a 3-lug. And I think it's pretty light. A lot of people will get to feel it at SHOT Show here in just a couple of days. We're going to have 3 actions there. With a 15-pound spring in here, and by 15 pounds I mean the spring is imparting 15 pounds on the striker assembly when the action is cocked. The effort required, I think, is easily acceptable, and thus far in testing, 15-pound spring has successfully ignited. I think they are the CCI number 34 primers, which are basically designed for use in the 7.62 military cartridges. So those primers are not very sensitive, so they're good to test with. What else here? Control round feed. Yes, it is a 3-lug control round feed action. I should have probably mentioned that in the beginning because that makes it a rather unique action. There's an ejector slot basically at 9 o'clock, and the extractor is located between the lug, the 12 o'clock lug, and I guess the 4:30 lug. But what really makes this extractor neat is that it's got this little doinkus, or this little protuberance, or whatever you want to call it, that extends downwards so that when the cartridge is in the bolt face, it is diametrically opposed to there's basically when the cartridge is in the bolt face, you have 2 diametrically opposed surfaces holding it within the bolt face so that as the bolt is retracted, the head of the cartridge doesn't drop down before it can get kicked out by the extractor that's going to pop through that slot there. Another thing that's pretty unique about this action is that it has 3 guide rails. You can see these little slots cut right into the bolt lugs, and you can also see, I don't know if you can get that. You can, well, okay, so there's within the receiver the channels for the lugs. The channels for the lugs have basically rails that run along with them that will engage the slots cut into the bolt head. So the result is it is very, not impossible, but this is not an action that wants to bind, not at all. It is just glass smooth, and those guide rails, their effect was rather surprising when I was designing it. I knew it would be a good idea, but I didn't know it would be that good. So, very pleased with that. The mechanical ejector, or inertial ejector, it's driven by the inertia of the rearward moving bolt. I don't know if you can see that there. It's a passive system, just like that of the Mausenfield and the 1903 Springfield. So that, what else do we have? Mechanical check. Bolt stop, I already went over the bolt stop briefly, right? You just flip it over. It uses AICS pattern magazines. No AIAW. Sorry folks, couldn't really get them to work in this thing. The action does not have an integral rail, nor does it have an integral lug. The lug and the rail and the lug actually cooperate with one another, so that you don't need to drill and pin the lug to the receiver for orientation. That works well. That's a patent pending feature. Yeah, I think it's pretty unique. I looked for other examples of it. I couldn't find it, so I think I'm running with it. I think I'm pretty happy with that. And then the finish, currently we're planning on the salt bath nitrided finish, black as you can see, and that's basically the receiver overview. Now I'm going to take you over the parts one by one. This is the receiver without anything in it. Again, 1 1/16" 20 thread for the Savage small shank. 1, 2, 3, 4, 5 tapped holes. They're 836. Number 8 screws, 36 threads per inch. Those secure the rail to the receiver by way of flathead screws, or actually, let's call them conical head screws, because the conical head is what's significant here. And basically, there's conical pockets or countersinks in the top of the rail, and when the two are bolted together, the rail really has no chance of going anywhere, because we're, as far as constrained, we have a very over-constrained condition, right? And once all 5 screws are preloaded, that's it. It's a done deal. What's more, moreover, the bottom of the rail sort of has like a V-block action with the receiver, so that when it's bolted and the screws are tight, just the way the rail engages the top of the receiver, it resists yaw, right? It naturally doesn't want to, rotate like this on the receiver. It just, it has sort of a self-aligning characteristic. So the rails are made from aluminum with a hard coat, anodized finish. They're 7075. Just so you know, 7075 aluminum is actually harder than mild steel. By mild steel, I mean, steel's having a yield strength of about 36,000 KSI. 7075 aluminum is up around 65,000 or 70,000 KSI. So they're rather durable. This portion of the receiver is the receptacle for the bolt stop, which is right here, right? So the bolt stop, basically, the way the bolt stop works, it's retained by this little screw on the opposite side, and the way it works is you basically just flip it over, and when you flip it, it no longer obstructs the lug channel through which the 12 o'clock lug of the bolt head travels. Extremely robust design. There's no pin to shear or to retain this thing. This is in effect a large pin that obstructs the bolt head and transfers the loads directly into large surfaces within the receiver. I think this is going to be, I think this bolt stop design will prove to be one of the best in bolt actions, period, like ever. There are some comparable designs out there, but it's certainly going to be as robust as anything found in a Mauser or a Springfield. That's the bolt stop. Oh, by the way, the bolt stop also uses a little ball and a little spring, just so you have some tactile feedback, and just to keep the bolt stop in the closed position. One other thing worth mentioning here, the center of mass of the bolt stop is actually in front of the axis about which it pivots, right? And that's significant because as the rifle recoils, the tendency is for the bolt stop to remain where it is. Had it been like if I oriented that way, recoil would tend to make the bolt stop move this way, and if that would disengage the bolt, that would have been a bad thing. So recoil, the forces of recoil act upon the bolt stop to maintain it in the closed or bolt stop position. So that's also worth noting. And that takes us through the bolt stop. We did the rail, we did the barrel thread. Here's the ejector. You can see, I'm not going to go ahead and put that thing in there, but you can kind of see what a mechanical ejector looks like. It's that little guy right there, and he pivots on that pin. And the pin has a thread in the bottom of it, or at the bottom of it, not in. It's got a little hexagonal socket, so you can put, and so the bolt stop will go in there and just run the pin in, and you'd screw that in just like that, and then the bolt stop will pivot on that pin. Again, the bolt stop, it's an inertial type system. It's actuated by the bolt head traveling backwards. As the bolt head travels backwards through the receiver, at least in a right-handed receiver, this lug on the left side will engage the bolt stop and force it to rotate so as to engage the case head. It'll kind of pop right out of there, just kind of like that. And the beauty of these designs, they're far better than any other ejection system that isn't passive. Like Mauser had something similar, although I think Springfield did the better job here, which is why I used this. This is the same bolt stop that's in the Mauser build, by the way. The Mauser bolt stop is actually, what's that? Oh, I'm sorry, yeah. My cameraman just pointed out that I'm calling the ejector a bolt stop. So sorry about the confusion. But yeah, so the ejector is better, in my mind, the Springfield type ejector is better than that of the Mauser, because the Mauser actually required a spring to drive it into engagement with the case head, whereas this is driven by the inertia of the bolt, that's a tremendous drop forcing function. So that's very, very good, and they're super robust, right? It's a little hardened steel part. There's nothing on it that can break. So in contrast, I mean, if you compare this to a plunger type, which is just, I shouldn't even bring it up because it's not even a real comparison, but they're just far superior to anything that would have to be actuated by a tiny little spring to push a plunger out of a hole that's in the bolt face, which is essentially ground zero for an overpressure event like a case head separation or a sneezed primer or something like that. So I think that's enough about the ejector. So where are we going to go from here? Let's talk about the extractor now and its cooperation with the bolt head and the and the bolt. And for this, just forgive me, I'm just going to run a cartridge real quick. Hold on a second here. Just to better show you here. Okay. We don't edit videos at American Rifle Company, as you can probably tell. So, just the information is important. So here's a, I don't know what this is, it looks like a 6.5 Creedmoor, right? So this is a control round feed system. So as the bolt travels forward through the receiver, it's going to strip the cartridge out of the magazine, and the cartridge is going to end up in the bolt face just like that. You can see that the extractor effectively holds the cartridge within the bolt face. That's important because as you're extracting, you want it, the extractor has to hold it so that it can deliver the cartridge to the back of the action where it can be engaged by the ejector and kicked out of the ejection port. This extractor, far superior to a T-slot extractor that used on Savage and by some of my competitors. Can't stress that point enough. Again, the bolt head is ground zero for overpressure events like sneeze primers, and just they get dirty. I mean, it's not a very friendly environment. So a robust extractor is very, very important. And the way this works, there's no spring, right? You saw the pieces, and there's three, right? There's a bolt head, an extractor, and a bolt, and they cooperate with one another to keep the extractor in the right place within the assembly. Now, the extractor and the bolt head, there's this forward surface right here in this pocket that's in the bolt head. It's undercut, and there's a lug right here on the extractor, the forward surface of which has a similar undercut, and those two undercuts will engage one another, right? And when they do, it prevents the extractor from moving radially outwards, basically it prevents the extractor from disengaging the case head by preventing its radial outward motion. And it's so that's like a geometric constraint or a form constraint on the extractor, which is in effect during the extraction process. So as the bolt is being cammed backwards through the action, those features on those two, that undercut feature in the bolt head and the extractor will engage one another to prevent that radial outward movement of the rotation. This is very similar, conceptually at least, to how the claw extractor on the Mauser works. The Mauser claw is still a superior system, which makes in my opinion, the Mousing field a superior action for basically this reason and this alone. There's no spring required to drive the extractor into engagement with the case head, and that is hugely significant. I guess that's not entirely true. Let me clarify that. The spring force biasing the extractor radially inwards comes from the tail of the extractor. This is in effect a leaf spring, and it's bearing against the side of the bolt to keep the claw of the extractor, or the hook of the extractor, biased radially inwards. But during the extraction process, right, the undercut maintains the extractor in the radially inward position and maintains engagement with the case head. So I really want to stress that point. There was a lot of time that went into the design of this extractor, probably more time put into that than any other part of the action, by far actually. And the way it's retained in the assembly, there's a little T-shaped lug right here, right? And by the way, the extractor is made of hardened 17-4, so it's really, really strong little part. So that T-lug is basically is accommodated by this slot in the bolt head, and there's a slot in the bolt right here that will engage the T-lug, and that's all there is to it. And now that guy is in there with that. There's no bolt head pin in at this time. I'm going to put that in a little bit here, and you can see it does a great job holding the cartridge. And you can we'll see if we can destroy this cartridge. I mean, you can, well, there you go. I mean, so, actually that's the first time I've ever done that. I never thought to do that before. But, yeah, we're not going to feed that thing anytime soon, so that's that. Anyway, so, good extractor. I think we've made that point. What else? What else? Moving through the bolt, there's a bolt head pin. Oh, by the way, the bolt head is interchangeable, right? Obviously, you can take these and get different ones, and with a different extractor, and do your caliber change. Although I don't know how you guys like changing calibers, man. Once I get a rifle together and running, the last thing I want to do is disassemble it. But you're the customer; you get what you want. Yeah, so that's the pin that secures the bolt head to the extractor, keeps it from coming out. That pin will be captured by the striker or the firing pin once it's fully assembled. The bolt, by the way, yeah, here's another thing we do. You get, with the Nucleus, you have integral bolt handle, right? Just like the Mousing field. So you're not breaking this off anytime soon. You don't have to worry about, well, it's one piece. I mean, enough said, right? It's one piece of hardened steel. It's super strong. That's not a bolt knob. This is a bolt knob. And here's another bolt knob. And we have a couple other types too that I'll get them up on the website here pretty soon. But this spindle, 315 in diameter. There's a 1032 tapped hole in here. Bolt knobs just screw on. And the thing I like about this design is that there's a steel shank basically running through the knob. The screw's way back in here, so it doesn't, you know, you can stomp on this knob if you get like a case really stuck tight, and you know, sometimes the heel of the boot is required to cycle in action with a stubbornly stuck load. What else can I tell you about this? Yeah, this knob, this is kind of new, and what this does, it actually moves the point of contact between your finger and the knob out by about a half of an inch, reducing the force required to cycle the bolt. However, with a 15-pound spring, I don't think that'll be necessary. However, you know, with that said, I kind of like this knob. It's sort of growing on me. I've been running it here for the past few days. Didn't know what I'd think of them. I've got some with knurls, some without knurls, and I don't know. I like it. I can warm up to it, I guess. But knobs are personal, and I think other people are making knobs for Mousing fields now, and a Mousing field knob will work on a Nucleus and vice versa. But I don't think they work on it. I think we're the only ones doing this, so I don't think anybody else does that. Cocking cams. There's dual cocking cams. We did that in order to minimize the forces required to cock the action. And basically what this does, this eliminates some bending moments associated with the cocking action that would otherwise lead to to contact forces. Basically, it reduces contact forces between parts. It reduces contact forces between parts. Those forces would otherwise contribute to friction. That gets pretty deep, but it actually doesn't. But I'm just not going to go too far into it right now. But suffice it to say, we did dual cocking cams in order to keep the bolt lift a little easier. The other thing we did here is you've got this little cut here, and what that does is actually it's better to show you on this action. It's similar to a Mauser and a Mousing field in that we've got a bolt head locking pin. Well, I'm sorry, a bolt shroud locking pin, and what that does, it prevents it prevents accidental rotation of the bolt shroud, with respect to the bolt body when the bolt is open. It also eliminates the need for a detent on the back face of the bolt that would otherwise be used to constrain or to prevent that bolt rotation. I'm sorry, to prevent the shroud rotation. This is a much more robust way to prevent shroud rotation, and it also provides more room for our cocking cam, and more room for the cocking cams means a reduced pitch on the helix, right? They're helical cams. We want to keep the pitch as low as possible because that keeps the cocking forces as low as possible. The striker assembly, firing pin. So here's a firing pin. The tip's been cut off. Here's what a proper one looks like. We just cut the tips off for SHOT Show. But basically, the striker or the firing pin, it's pretty heavy, and we made it heavy again so we could reduce the cocking forces. A lot of this design is driven around keeping the cocking forces down. We worked really hard to do that, and I think when you guys finally get these in your hands, you're going to be like, wow, they really got it right. The pin, I believe, is the pin and the spring for short action is 55 grams. I think what I'm going to do is have multiple springs available. We'll probably start with 15-pound springs and then maybe do like a 17.5 and an 18. But I think 15s are going to be adequate. I think you'll find that they will keep the cocking forces very light, and they will reliably ignite the CCI number 34 primer. So the firing pin passes through the cocking piece like this. They're screwed together, right? That's a 3/8 32 thread, really fine. And the firing pin has a head basically on the end of it, which prevents it from being screwed all the way through the cocking piece. The reason I like this design is the same thing that I've been doing on the mousing field. It's just super robust. It's really robust. I don't feel comfortable with firing pins pinned to a cocking piece. Remington's gotten away with this for years. That says a lot about that design, but I need to sleep at night. So what I really like is a threaded connection and a headed pin, so that the two are once together, they're essentially one piece. You will want to Loctite this. We actually Loctite them here before they leave here. We just use blue Loctite. A little bit of heat or a really strong grip can disengage it. Here's a spring. I'll show you how this whole thing goes together. What you want to do to put this thing together. When you buy one of these, either Mousing Field or Nucleus, they come with this little screw and washer and this big washer. And what you do with these, this screw is used to facilitate disassembly and reassembly of the bolt. And there's a tapped hole in the back of the firing pin. There's also a hexagonal socket in the back of the firing pin. You can actually get a wrench in there, right? But you just want to start that, right? Just a little bit, just 1 or 2 threads. Stick it through the cocking piece, right? And then you're going to sit it down on the screw head. I cut this spring really short, so it could be really easy to do on the video. So you put your spring over your firing pin, and then you're going to use this washer and this little nut, right, to hold the spring back. Now this can be pretty tricky to do. The way this system works, here's a thread here that engages this nut, right? But this thread has basically a hexagon cut right over it, so it's like it's a threaded hexagon. This little washer here has a hexagonal through hole, and this little guy goes over the hexagon, and rotation, he can't rotate with respect to the firing pin. He can slip over him, but he can't rotate. And this little washer guy, he's got 1, 2, 3 little lugs that protrude from the face. The nut has 6 little recesses that are designed to accept the protrusions of the washer. So when we put this together, right, you're going to put the washer in first. This is actually much more difficult to do with a proper spring, so I am cheating here, and you know, be it known that way the trolls don't get on, oh, he's using a fixed spring, whatever. But yeah, so now this big washer is going to engage this little washer has a flange, right? I don't know if you can see that, I hope you can. And the flange won't fit through the hole in this big washer. So this is your bolt, this is your striker disassembly tool right here is a big washer. And you might want to do this with 2 people if you do it on the real thing. Suggest that you don't do it because I don't think you have to really. So you're going to push down on this guy. I got lucky there. So you push down on this guy until the hexagonal part, the threaded hexagonal part of the firing pin appears through the washer. Then you take this little nut and you screw him down on there, right? And with this, you can also adjust your firing pin protrusion, right? Which I don't really recommend. I think once you get it right, you want your firing pin protrusion to be about 35 or 40 thou. And just to clear up a little myth associated with firing pins and light strikes, a lot of people, you know, if they get a light strike, nearly everybody says, hey, I need more firing pin protrusion. That might be the case if you didn't have enough to start with. And by not enough, I mean something like, you know, 10 or 15 thou, even 20 thou in a tight chamber will set off a primer. 20 thou protrusion, that is. If your protrusion is 30 thou and you're not setting primers off, that's not a protrusion problem, and increasing protrusion will actually make the problem worse because it actually reduces the energy released by the spring, you know, when the trigger is pulled. So maybe we'll go into that a little deeper in another video, but just wanted to get that out there. So once that's on there, it can't rotate now with respect to the firing pin. It's basically locked in place. The little protrusions on the washer have interlocked the recesses on the nut. And then this whole thing, at this point, you want to take the screw and screw it in all the way. That's going to pull the firing pin back, right? And when you pull the firing pin back, you pull back you basically pull back the nose of the cocking piece, or the noses in this case, because it's dual, it's got 2 of them, right? That way, as you screw it into the back here, you know, the cocking pieces the cocking piece doesn't keep dropping into the cams, so it's really easy to do it this way. Now, a lot of people are going to say, hey, why don't you use like a bayonet style fitting between the bolt shroud and the bolt? And the reason for that is I'm just not comfortable with it. If you look at the original Mausers, they use buttress threads, which is a very strong thread, resists axial load in one direction extremely well. We use very good materials. All this is hardened steel, really strong stuff. But basically, in the event of like really, really bad overpressure situations, I don't want to blow the striker assembly through your face. That's why I don't use bayonet style fittings between a bayonet style, you know, engagement between these two. By bayonet style, I mean what it would otherwise be would be just a smooth cylinder with no thread, and then just like a little lug. And the lugs are tiny for that. It's a ridiculous. Personally, I think it's a ridiculous design. I hate it. But so I stick to a tried and true thread. The other thing about this action and the one thing to note is that it has a flanged bolt shroud, just like the original Mauser. And what that does when it's in the receiver, basically that flange provides a nice obstruction to rearward traveling particles and gases resulting from overpressure events like case head separations and sneeze primers. We take safety seriously. I mean, you're putting these are essentially pressure vessels. There's a 65,000 psi firing event taking place next to your head. So, I mean, we take that's a sobering thought, you know, and we take it seriously. The other thing we don't do, a lot of people ask for a right bolt, left port. I won't do that in a field action. I might consider it in a bench rest action because those guys generally control conditions pretty well. But in a field action, I don't want to do it. Again, I don't want to put a gaping hole in front of your face. The ejection port is just too big a hole and it extends too far forward to the chamber. We have the extractor port or the ejector port on this side. I'm much more comfortable with that. A, because it's small, and B, it's much further from ground zero being, you know, where the pressure is, which is up in front in action. So that's that. And what else do we have here? Yeah, so the bolt shroud, let's just continue the assembly on the bolt. So here's our bolt with our bolt head and our extractor. We're going to put that guy in there, screw this in here. All right. Okay, so once you have that together, there's a hole in the bolt shroud right here. Line that up with this little cut for the locking pin. Here's the bolt shroud locking pin right there, that little guy. He goes in there. You can put this spring in behind him. And then I've got a nice fancy little set screw that we have custom made because it's got a really nice finished look to it. This one needs a little tweak actually, it's not sitting exactly how I'd like it to. Actually, before I do that, I need to remove this. Take that guy out. And then put this guy back in. So it's not, I don't make toolless disassembly and reassembly a priority. Some people have asked for that, but I don't know. I like, you know, I just kind of like it the way I do it. I think the use of screws kind of makes for a more robust design, and yeah, I guess that's why. I design this stuff, I reserve the right to do what I want. Screw the bolt stop on. That's done there. And then this whole guy, you can stuff this thing in there. Now, to put the bolt stop in, that's a pretty easy deal, right? You need this little spring. The spring's going to go in this hole here. Oh, hold on a second here, let me get that guy there. Right, drop the spring in the hole and put the bolt stop in. But when you put the bolt stop in, it's just easier to do without the bolt actually. So put the bolt stop in there, and then you take this little ball, and I don't suggest, there's no reason to disassemble this thing in the field, so don't. Otherwise you're probably going to lose the little spring and the little ball. But it's pretty easy to do at home, or you know, on a table like I'm doing it. So put the little ball on top of the spring, then push the ball down with something, and then just push the bolt stop in. And you can see the detent there that maintains the bolt stop in the, you know, the obstruction position, I guess we can call it. So you can rotate that by 180 degrees, pass the bolt by it. We should actually put the locking screw in. We'll do that in just a second. And then the bolt has to be almost fully retracted to reinstall the bolt into the receiver. You'll see, once you do it once or twice, you'll get it. It's pretty easy to do. The bolt I'll show you here. So when we put this guy in, all right, I'm just going to tighten that guy up a little bit. And so if the bolt is forward, the bolt stop doesn't rotate. That's another little safeguard against accidental disengagement, and then you end up pulling the bolt into the comb of the stock or into your face. So that's hard to do with this design. You really have to, the only way to do it is to literally forget this in the open position, and then to open it, it has to be retracted. Once you feel it once you feel the bolt lug strike the bolt stop, then you can rotate it and it comes right out. Same thing with putting it back in, right? Slide it in a little bit, rotate till it stops, pull it back, you'll hear it hit, and then just close it and off you go. I'm not going to screw the rail down. I know you guys know how screws work, but I will show you the details of the underside here. The recoil lug engages that slot. There's a slot right there that's cut into the underside of the rail that prevents this from rotating. You don't need to be concerned with the forces preventing this rotation, there's a fastener in close proximity to the slot, and the rail is extremely strong and stiff, especially in the horizontal plane. So that actually works really, really well. The other thing I'm going to do, the nucleuses that all you guys are going to receive, since nobody's received one yet, there's a design modification coming on the bolt stop. I'm actually going to reshape the lug so as to obstruct the rail from forward motion. So the recoil lug is actually going to be a recoil lug for the rail as well. So the rail prevents recoil lug rotation, and the recoil lug prevents any, although there's no way it would have moved with 5 conical head screws, but as an additional safeguard, because I know people are going to ask the question, so let's just put this to bed right now. We will have a bolt stop that also obstructs any forward rotation of the rail. What's more, we will probably tweak this rail design for better bar lock integration, and that'll be part of another video. Bar locks are still really new, so there's still a lot of work to be done there. But we're delivering the first bar locks here pretty soon, just a couple of weeks now. I think that's everything. Again, this is American Rifle Company's Nucleus. Come visit us at booth 20,459 at the SHOT Show 2018 in Las Vegas, Nevada. The show starts this Tuesday. I don't know, do you know what date it is today?
The 23rd.
Okay, yes. So the show starts on the 23rd of January, which is this Tuesday in Las Vegas. And that's it. Sorry about the length of the video. I guess I should shut up now and just say thanks for watching. And come see us at the show. We'll have 3 reactions there. I hope you enjoyed it. Take care.